Okay, making another, geez, can't talk. Alright, making another recording here to test, because I had some problems with my last recording there, kind of the video cut out. I'm thinking maybe like if it might be just because if I don't move around and do stuff all the time, if I leave the same exact screen state, that maybe it screws up the recording. But anyway, I switched it from the Intel QuickSync thingy. You know, it's like a setting in bandicam using the NVIDIA encoder now. So I don't know. Hopefully it'll be different and it'll still work. But in the last video, I got the audio down, and actually by the time that the video cut out, I wasn't doing anything interesting anymore you know, looking at my code and whatnot. So that's fine. Yeah, I think I pretty much got through all of the just kind of like motivations, kind of like what you know, what I'm trying to do. Kind of, it was really kind of vague. Exposition. It wasn't great exposition. It wasn't anything. It was completely spontaneous. You know. I guess for the purposes of this test, what I'm going to do is basically probably I'm just gonna continue recording while I do work. You know, and just kind of, not so much stress test, but yeah, basically just test, right? So, you know, we might get long periods of silence. We might, you know, and also I guess I also have to look into kind of the oh, you can listen to me swallowing, yes. But there's also this kind of issue with I'm not going to talk louder, right? I'm not going to, like, maybe we can turn up, let's see, maybe I can turn up the volume, turn up the gain or something. It's like, it's already up there. I don't really know what's happening. Is there set up the microphone? That's a microphone. I don't know. There's no gain setting, which is kind of strange. But there's like this clicking noise, right? There's this like noisy, you know. And I already know that I can't use the audio device, the microphone input on my motherboard, because those things are just notoriously bad. You know, as of late, the audio output has been quite good. You know, I'm still using that with my Sennheisers, and the audio coming out sounds absolutely fantastic. But the quality of the built-in microphone input is just so bad, right? So I've got one of these USB thingies. We got one of these USB. Yeah, I'm not gonna scroll through on my Amazon order history for you, but yeah, I got one of these USB sound cards that I have plugged my microphone into. So that's what I'm using now. But even with that, right, I thought it would be kind of cleaner, and it is. The noise level is pretty low, but there's like this weird like clicking, like, I don't know if it's like interference. I don't know what it is. Yeah, I mean, it's acceptable, right? It's kind of sort of acceptable. It's not really it's not really acceptable, but it kind of is. So so I don't really need that either, and So this was a change that I just made recently because what I'm currently working on is just proof of concept, and what I'm doing with this is as I'm using match finder, using a front-end action factory with a match finder with a record decal and field decal matchers, which match record decals that have fields and fields. And so on all of those, I'm just matching them, and I'm making a C-style comment replacement, inserting the replacement in both cases. You know, in the replacement, where's the replacement? Get replace tool has replacements. Let's replacements. Decal handler. Oh, I just passed it in, right? Okay. Passing replacements in. As I match, I insert replacements, and then at the end, out here at the end, I kind of just dump out the replacements using outs, and that's what we're seeing on the right side here, the output from before, which is you know, and the first four, these are, yeah, I'm not really sure why it's got no line numbers only on the first four here, but yeah, I think these line numbers are not line numbers that you can really oh, those are character offsets, right? Okay. So yeah, I'm sure those are correct, right? We verify the character offsets. So 2055. You know, if you look on the bottom here, I've got a special Vim status line that has the byte offset of the characters. So that comes in handy once in a while. This is one of those rare times when it does come in handy. Now 2055. I don't even know why I'm doing this. Why am I doing this? This is 2055 right here. Struct member T, right? Member T. So that checks out. But yeah, basically these three here are because of expanded macros. I don't know if it's like just one level of macro expansion makes it that way, but that is what that is. So this is all I have right now. But it's already extremely promising because without this whole clang thing that I've set up, there's no reasonable or sane way to go about parsing source code to like find all the class declarations. There's a lot of different ways of defining classes and structs and unions and enums and just defining stuff, right? And the syntax is just not, it's a parser, dude. You gotta have crazy you gotta have your compiler. Your compiler is the only thing that's actually reliably able to semantically parse this. It is guaranteed to semantically parse it, in fact, right? That's why this whole thing is quite elegant and beautiful. You know, because we have our compiler, it is open source. I've built it many times, and you know, we're directly interfacing with it. We're building with the compiler to make these tools, and we have, you know, in addition to all that, we have all of these nice APIs like declaration matchers. You know, it's like, yeah, this is kind of ugly and Lisp-like, but you know what? It's not bad at all. You know, it's a DSL, and it lets you drill in and kind of pick out only specific items that you're interested in. So it's like really powerful. You know, and you have the full power of C++, with C++ 11, you know, just do anything like this. So, you know, I mean, the next stage might be actually that I'm gonna look for what the actual. I don't know. I mean, a lot of these pieces have to be built together in parallel, right? So now that I've found the CXX record decals, I can essentially just do this right here. Instead of inserting a comment, you know, I have to find the offset to where the open brace. Should probably put it at the end, right? So I'll find where the end close brace of your CXX record decal is, and you know, insert a bunch of static methods that are responsible for you know, basically efficiently dumping the contents. What I did before, in this toy example, is, well, I don't actually have any of the instrumentation. I don't have any of the client side kind of like output stuff here. So all I have here is kind of just implementation of the static members. So you have to call these members. So it has to be like, you know, it have to be like bar colons. I don't know, bar colons members, and that's like a static function call here, and then you get the underscore info on the type, and you get its members. Okay, that's not the one, but you get what I'm saying, right? It's like really it's really crazy in here, right? But you know, we're gonna instrument with the full power, right? The full Turing complete power of C++. So we're gonna have our static instrumentation methods in there. They're gonna be able to go in. They're gonna be able to go in and, you know, because I'm gonna be building in here, right? I'll have a complete map of the types and names and I mean, I guess sizes, but it's not that important. But like, those are the parameters, right? The names, the types, and the sizes. Those are like the relevant pieces. You know, I'm gonna have those, so I'll be able to like take those and surface that information in whatever method that I decide is ideal. You know, in this case, and that's most likely going to be JSON. You know, this is going to form the implementation, the actual implementation of the tool, which is going to be big, right? It's going to be a big tool. It's going to be kind of like short and sweet as much as possible, but you know, just to be able to cover all the bases, because this is huge. This language is C++ is unimaginably huge as far as languages go. You know, but like I mentioned though, right? Like if you have a class, there's only so many things about its state that you can kind of, you know, that are mutable, and you can kind of dump out, right? Like I'm not gonna have the interface like allow you to like look at like source code for all the methods, you know, like dynamic like hierarchy, right? Inheritance hierarchy of your class. Like that's not in scope here, right? That you've got other tools that you should be using. If you're interested in that information, you should just be reading your source code. If you're interested in that information, right? What I'm talking about using exfil4. I'm sorry, I have to learn how to talk. Yeah, I'm sorry. But you know what you have to actually use exfil4 is you have to use it to exfiltrate the type of information that is ordinarily extremely painful and complex and not straightforward to reveal in a friendly way normally, and that's generally going to be the types of data that is extremely mutable, or just moderately mutable, or I mean, I guess what I mean to say is that any state that is mutable at all, ever, and it's like it's going to make it easy and straightforward for you to do it, to surface the changes and view the changes, inspect the changes, monitor the changing state of your data structures as algorithms proceed. And that's basically it. So we do spend a lot of time kind of just looking at plain old data structures, and cause that's where most of the interesting things happen. That's where most of the interesting things happen. You can certainly have like lots of convoluted logic. Insane like branching, function calls, things of that nature. And really, that's hand in hand with algorithms, right? Most elegant algorithms don't have large, branch structures in their logic. But we also do have to accept that in the real world where business logic matters, you end up with a lot of branching, a lot of cases, stuff like that. But the point is, that's all fine, and it's orthogonal, right? It's orthogonal. If your program, if your algorithm is extremely complex, it has many stages, and you have to dump out state, at a higher granularity in order to follow what's going on. Well, then maybe it's going to take you a little more time. You have to put in a few more, than usual. You have to put in some more instrumentation statements. Then so be it, right? You only have to you only have to do it once. You only have to do it once, and the magic is going to be, well, there's a lot of magic everywhere, I suppose. It's going to be being able to move back in time, being able to have your instrument program to know how to store within itself and process it for itself efficiently the exfiltrated data, so that you can access it in a way that is user friendly, and that's basically, that's all there is to it,